All right, what's up, students? Now, check this out. This football player would give high five to the other player. Why? Just for saying hi? No. The reason is what? Yes, the other player would substitute for him so that the game would continue. Guess what? In math, there is also substitution, and we use that for linear equations. And that's the lesson for today. Are you ready? All right, here we go. All right, so today's lesson, we're going to study the ways to solve systems of linear equations. Remember in the past we studied graphing, right? There is an equation, the one in red. You graph that line, and then we have another equation in blue. Then we graph that line wherever they meet, this one. That intersection is called the solution. And how did we do that? We used the method called graphing. Okay, today there's another way. There could be other ways, but this is just the second. It's called substitution. So how are we going to use substitution? Now, check this out. So if y is equal to this equation and y is equal to that one, they're different, right? So this is what we're going to do. We're going to equate or substitute the equation. Make it equal to each other or substitute. Number two, we will solve for one variable, either the x or the y. Since you already got one variable, you will now solve for the other variable. Now you have the x and y, that's already your solution, right? Now you already have a solution. What will you do? You simply check if it makes sense or not. Okay? I will now demonstrate to you how to use substitution. Okay, so look at this. Y is equal to this expression. Y is equal to that expression. But these y are the same, right? So I could substitute one to the other. Instead of writing y, I could put negative x plus 7. Instead of writing y, I could put 2x plus 1. So they are equal to each other. Or let's make them equal to each other. Let me start with 2x plus 1 is equal to the red one, negative x plus 7. All right. Since you see an x on the left and an x on the right, see that? And this one, I want to gather them together. All right. So what do? I get rid of u minus x becomes a plus x plus x. Okay. That cancels out. This becomes 3x plus 1 equals 7. Okay. Next, minus 1. That cancels out. 3x is equal to 6. What's next? Divided by 3, divided by 3. X is equal to 2. All right. So guess what? We were able to solve for the variable x. We equate them first because they are the same. We're done. Number 3, since I already know the x, I also need the value for the y. Solve for the other value. Well, how do I get that? Use any equation. Equation. All right, so let me try the one in blue. Y is equal to 2x plus 1. Remember, I already know the value of x. So y is equal to 2 times 2 plus 1, right? So what do I do next? 2 times 2 is a 4 plus 1. So y is equal to 5. Okay, so I already have a value of x and a value of y. Put them together, my solution is 2 comma 5. Actually, you're done at this point because you already know the solution. But you want to check if the solution makes sense. Let's start with the blue one. So let's write the blue one. The blue equation is 2x plus 1, y is equal to 2x plus 1. Since I already know that y is equal to 5, I plug in 5. X is 2 plus 1. 5 is equal to 2 times 2 is a 4 plus 1. 5 is equal to 5. That makes sense. It's a true. So our statement is correct. Now, let's try the equation in red. Y is equal to negative x plus 7. Since I know that my y is a value of 5, I plug in my x, which is a negative 2 minus and a positive 2, plus 7. The left side is 5, the right side is 5. That's a true statement. So I'm okay with the first equation. I'm okay with the second equation. So I am very sure that my answer is correct. See, that's how you do systems of equation by substitution, by equating them. Okay, initially you want to equate them, make them equal, just like the previous one. X plus 3y is equal to 4x plus 2y. But you can't do that. Why? Because look, the other one is equal to 30, the other one is equal to 15. They're not equal to each other. So they cannot be equal. So we cannot use the previous method. Therefore, we will use the substitution method. All right? So we will use the substitution here. Substitution here. Okay, but if you look at the red equation, we want one of the variables should be alone. So normally we want the y, but it can also be the x. So what do? I need to get rid of u minus x minus x. That cancels out. 3y is equal to negative x plus 15. I need to get rid of u divided by 3 on the left, divided by 3 on the right. That cancels out. Y is equal to negative 1/3 x plus 5. So that's an equation now. This is the same with that. I just changed it so that y will be alone. We want y to be alone. Now, should the other equation, should the y be alone still? You don't need to. Why? Because we will use now substitution. Substitution. Okay, so check this out. I write copy 4. I copy x. I copy 2. Here we go now. This is the substitution. Instead of using y, go back to here. Instead of using y, I could use the whole expression. Why? Because this one is equal to that one. They are the same. I can apply my substitution now, right? Just like the football players, the other will substitute for the other. Okay, so look, instead of writing y, I write the parenthesis negative 1/3 x plus 5, okay, equals 30. All right. So now I remember my distributive property. So that's going to be what? For x plus negative 2/3 x plus 10 equals 30. Okay, we need to add these two x's together, like terms. 4 minus 2/3, think of 4 whole number minus 2/3. That's going to be 3 and 1/3 x plus 10 equals 30. You can change that to improper. That becomes 10 over 3 x plus 10 equals 30. Get rid of this plus 10, minus 10 for you, minus 10 for you. That cancels out. 10 over 3x is equal to 20. How do you get rid of a fraction? A times a fraction, multiply by the reciprocal. So that becomes 3 over 10. Guess what? That cancels, that cancels. So I also multiply this by 3 over 10. So therefore, x is equal to, this is like 60 over 10. X is equal to 6. Finally, we got a value for x. Okay, but Ram, we still need the y. Okay, we got one variable. Check. We will now get the other variable. Okay, let's use this equation. Let's use the same equation here because y is already alone. So let's use that. Y is equal to 1/3 x plus 5. Again, this is similar to substitution. Y is equal to 1/3 times, what is our x? Our x is 6. Okay, then add your 5 again. Okay, what is 1/3 of 6? That's becomes 6 over 3. 6 divided by 3 is 2 plus, no, 6 divided by 3 is 2 plus 5. All right, so y is equal to Y is equal to, oh no, we forgot. There's a negative here. There's a negative there. Therefore, there's a negative there. So our answer should be what? 3. Okay. So now you have an X, you have a Y. What is our solution? Put them together. Put them together. Our solution is 6, comma 3. Okay, this is my X. This is my X, and this is my Y. Okay, now, solution done. Check if it makes sense. Ah, a lot of work. Check. Okay, let's try it. The one in red. So x plus 3y equals 15. So x is 6 plus 3 times 3 equals 15. 6 plus 9 equals 15. 15 is equal to 15. That's a true statement. Let's try the equation in blue. For x plus 2y equals 30. So 4 times 6 plus 2 times 3 is it equal to 30. 24 plus 6 is equal to 30. Left side is 30, right side is 30. It is true. All right. So this is our checking. Checking works. Therefore, I am very sure that my solution is correct. Now let's try this ingenuity problem. What is the solution for this system of equation? Okay, guess this what? Guess what? The y is alone. That will help us even if this y is not alone. All right. So what can I do? I can now substitute uy over there. All right. So let's write down the equation. 2x minus, instead of writing y, remember, instead of writing y, I will write the other one. Okay, because here it needs a y, I will put y here. Instead of y, I will use this. So check this out. Instead of using y, I'm going to use minus. So I put a parenthesis, negative 1 half x plus 5. Okay, and it says equals to 10. Equals to 10. All right. So, but there's a negative outside the parentheses. Remember, if there's a negative outside the parentheses, it affects the inside. You do your distributive property similar to that. So, negative of a negative is a positive 1 half x. A negative of a positive is a negative 5 equals 10. You can combine 2 plus 1 half is 2.5. X minus 5 equals 10. So get rid of minus 5 plus 5 for you, plus 5 for you. That cancels out. 2.5x is equal to 15. All right. So next, divided by 2.5 divided by 2.5. How many 2.5s can you get in 15? So in 5, I can get 2. So 5, 10, 15, 2, 4, 6. So the answer is 6. So now I know x is equal to 6. Guess what? I can also solve for the y. Look at this. Use the other equation. Y is equal to negative 1 half x plus 5. So let's substitute negative 1 half times 6 plus 5. Half of 6 is 3, but it's negative, plus 5. So y is equal to 2. Now my solution, our solution will be x comma y. So that's going to be 6 comma 2. All right, so that's the answer. Are you sure you're right? Let's check one equation. Let's check one equation. Let's check the first one. 2x minus y equals 10. Substitute the x of 6. Substitute the y of 2. Is it equal to 10? This will be 12 minus 2 equals 10. Left is 10, right is 10. I am sure I'm correct. Let's use the other equation. Y is equal to negative 1 half x plus 5. Now, Instead of writing y, where do I get those xy? Remember here, if you're confused, this is the x and this is the y. Instead of writing y, I write 2. Instead of writing x, I write what? 6. And then plus 5. 2, this becomes half of 6 is 3, negative plus 5, 2 is equal to 2. That makes sense. So here we are checking. The checking guarantees that my answer is correct. Now, sometimes you don't need to solve so that you will know that there is one equation. How do you do that? Okay, check this out. So let's start with these two equations. So they're equal to each other, right? So guess what? If their slopes are different, are you sure, Ram? Yeah, look at this, negative 3 and positive 2. If the slopes are different, you can already guarantee that there is one solution. Meaning what? This positive line and this negative line, okay, will meet at one certain point, and there's only one point where they're gonna meet, one solution. How would you know that without graphing? Look at the what? The slope, if they're different. Are you sure, Ram? Okay, yeah, we're sure. Let's check it out. Since they're equal to each other, so let's write equal to each other. This one is equal to that. So what do I do? Put the x together, minus 2x for u, minus 2x for u. That cancels out. That becomes what? Negative 5x plus 4 equals negative 6. I need to get rid of u, minus 4 minus 4. That cancels out. Negative 5x is equal to negative 10. Divide by negative 5. Divide by negative 5. Cancels out. X is equal to 2. See that? The solution, x is equal to 2. There is one solution, right? Now, just for the sake to get the other one, y is equal to 2x minus 6. I use one of the equation so that I could get the value for y. 2 times 2 minus 6, which is 4 minus 6, which is negative 2. So we know that's the y. Yes, our solution is 2 comma negative 2. We are very sure that the two lines will only meet at 1.2 negative 2. Again, you don't need to graph. What will you look at? You will look at the slopes. If the slopes are different, they will meet at one point, only at one point. Okay? Now, check this out. Sometimes the two lines wouldn't meet. This line will not meet that line. All right? Okay, let's check this out. How can that happen without graphing? Check this out. Okay, I want the x to be together. Minus 2x for u, minus 2x for u. That cancels out, that cancels out. Oh my God, my x disappeared. And what remains is 4 is equal to negative 6. Is this a true or a false statement? That's false. It can never happen. All right? So, what can you say? If your x disappeared and the left is different from the right, you could say there is no solution. That means what? The lines are parallel. Parallel. Okay, clue. Look at the clue. How will I know if the lines are parallel? Check this out. The slopes. The slopes are the same slopes. You see that? They both have the same slope. Same rise and run. But check out the y-intercept. The y-intercept are different. So that's the clue. If you don't need to graph anymore, if you see if the slopes are the same, they won't meet. Wherever you do, they won't meet. Okay, next. For the next example, okay, let's graph both of them. But look, they're equal to each other, right? So let's solve for x first. What will happen? Guess what? I want the x to disappear, so plus 3x for u, plus 3x for u. That cancels out, that cancels out, so 8 is equal to 8. That's a true statement. Whatever you plug into x, it will make that statement true. That means what? And they're the same line. Guess what? If 3x plus 8 would look like this, if this is 3x, negative 3x plus 8, the other line would also be what? Negative 3x plus 8. Negative 3x plus 8, one on top of the same line. See that? And if one line is on top of the other line, where did they meet? They will meet at infinite number of points. That's why it says infinite many solutions. Okay, so not just one, but infinite number of solutions. And how do I know without graphing? Check this out. If the slopes are the same, -3, -3. What else? If the same y-intercept as well, +8 and +8, because they're the same line. Obviously, one is on top of the other. That's infinite number of solutions. They're the same. A system of equations is given below. Y equals -3x plus 6. The other one is y equals 6 minus 3x. Which of the following statements best describes the two lines? Okay, so let's see whether they have no solution, one solution, no solution, or infinite solution. How do we know that without graphing? Let's look at the slope and the y-intercept. Now check this out. The slope, the m would be the slope, the one in yellow. So you are the slope, -3, -3. What do I see? They are the same. Ooh, they're the same. Now, let's look at the y-intercept. The y-intercept is the +6. Here, it's also a +6. So, the b is the y-intercept. Y-intercept. Okay? And what have you observed? They are also the same. Same slope, same y-intercept. So, it's the same line, right? So, what can you say if one line is on top of the other? They have what? They have infinite number of solutions. So this is the answer. Okay, next. So we have two equations again. Now y is alone, very good. It will make our lives easier, meaning they are equal to each other. So if they're equal to each other, let's write down 1/2 x plus 6 should be equal to -3/4 x minus 4. Okay, so let's get rid of this one, plus 3/4 x for you, plus 3/4 x to you. That cancels out. So 1/2 plus 3/4. Now guess, look at this. 3/4 will get the 1/4 from 1/2. That's 1 and 1/4. 1 and 1/4 x plus 6 equals -4. Okay, get rid of plus 6. Minus 6 minus 6. That becomes, let's make it improper. 4 times 1 is 4 plus 1, 5/4. 5/4 x. That's the same thing. Equals -10. How do I get rid of times 5/4 times the reciprocal? Times 4/5. So therefore here times 4/5. So that cancels out, that cancels out. X is equal to -40 over 5. X is equal to -8. So there we go. We know you're right. You know we're right because you got the -8, not you. Okay, how do I know the y? Just substitute. Let me substitute it to the easier one. Let's use this. Y is equal to 1/2 x plus 6. That becomes 1/2. What's my x? -8. I plug in -8 plus 6. What is half of 8? 4. Since it's positive times negative, negative plus 6. Add a positive and negative, that's a positive 2. The y should be a 2. Therefore, this is the correct answer. Okay, again, one more. It says, what is the solution to the system of equation before? The first one is y is already alone. Very good. Y is already alone. That means this one is equal to that. So makes our life easier, right? So since the y is already alone, so u are equal to that one. So let's write it down. -1/3 x plus 9 is equal to 2/3 x minus 12. Okay, put them together. -2/3 x for you, minus 2/3 x for you. That cancels out. That becomes negative 3/3 x plus 9 equals negative 12. What is negative divided by negative? That's negative 1. So negative x plus 9 equals negative 12. Minus 9 for you, minus 9 for you. That cancels out. Negative x is equal to negative 21. But x is negative. How do I get rid of that? Divide it by negative 1, divided by negative 1. That cancels out. X is equal to positive 21. All right, so positive 21 could be this or this, but not this. Okay, so let's substitute now. Let's use the first equation. It looks easier. Y is equal to negative 1/3 x plus 9. Substitute your x. Negative 1/3 times 21 plus 9. All right. What is 1/3 of 21? Just divide it by 3. You get a 7. Negative 7 plus 9. All right. That becomes positive 2. Put them together. That becomes 21, comma 2. And the correct answer is that one. That's the solution. Okay, for this last problem, yesterday at 1 p.m., Maria's train was 42 miles north of Gulls Beach, traveling north at an average speed of 90 miles per hour. At the same time, the adjacent track, Elena's train, was 6 miles north of Gulls Beach, traveling north at an average speed of 101 miles per hour to the nearest hundreds of an hour. After how much time will the trains meet up? So two trains will meet up. Let's start with the first train. Okay, 42 miles already at 42 miles, and the speed is 90 miles per hour. So the distance will be like this. The distance traveled will be, he's already at 42 miles, okay? But the speed is what? 90 miles per hour. And we don't know how many is that. So that's going to be the x, all right? Now, let's look at the other one. The other one is 6 miles north, traveling at 101 miles per hour. So let's make an equation out of that. That becomes y is equal to, he's already at 6 miles, but the travel is 101. We don't know the number of miles. Oh, the speed is 101 miles per hour, but we don't know what x is. So plus 6. Okay? So we have two equations. The good thing is they're equal to each other. So y is equal to that. Why are they equal? Because they will have to be at the same time where they meet up. So when they meet up means they are equal to each other. So let's make them equal to each other. Let me start with the blue one. So 101 x plus 6 is equal to the red one, 90x plus 42. Okay, let's gather the x together. Let's gather the x together. So minus 90x for you, minus 90x for you. That cancels out. 101 minus 90 is 11x plus 6 equals 42. Okay, let's get rid of the plus 6, minus 6, minus 6. That cancels out. So the remaining would be 11x is equal to 36. Okay, divided by 11. Divided by 11. X is equal to, if you get your calculator, 36 divided by 11, you will get 3.27, and that's the number of hours. Look at the choices. There you go. So that's how you solve using substitution. Okay? Remember, students, results is equal to action plus motivation. Good luck.